right, I want to just take a quick look at what we get if our integrand for a surface integral is just 1. Thinking about what this means, I would be attaching a constant height of 1 to every point on my surface S. So if I'm thinking of this in terms of a signed volume, that volume would be the area of the base, which would be the area of S, times 1. So this should just be the surface area of S, of my surface S. Okay. And that's exactly what it is. And this is analogous to what we've seen before, that if I integrate from a to b 1 dx, I just get b minus a, which is the length of the interval. And if I integrate over a region D, 1 dA, I get the area of D. And if I integrate over a region E, 1 dV, I get the volume of E. Okay. So anytime my integrand is 1, I'm just getting the appropriate geometric measurement of the region over which I'm integrating. Kind of nice to see that consistency, and it's also kind of neat to see how this plays out and helps tie together a couple of things. So if S is parametrized by R of uv over a region D, this would become, I know, the double integral over D of 1 would stay as 1, but I'd get my scaling factor that would allow me to switch from ds to dA, and that scaling factor would be the magnitude of this cross product of the partials of R with respect to u and v. But that's exactly the formula for surface area that we saw in section 16.6. On the other hand, if S is the graph of z equals f of xy over some region D, this becomes the double integral over D of the square root of the partial of f with respect to x squared plus the partial of f with respect to y squared plus 1 dA. That's what this is if I use the parameterization where I set x equal to u and y equal to v, and then don't bother to change the names from x and y to u and v. And that's exactly the formula we had for surface area back in the previous chapter. So kind of neat to see that playing in, and it also means there are fewer formulas to have to remember. That if I remember that this is what allows me to switch from a ds to a dA, that's what I integrate if I want to find surface area. Same thing here, just depending on how I've described my particular surface.